All right, class, at this point in time, you should have watched the video on Schmoop. Good job for doing that. Proud of you. You have completed watching the video on Schmoop. Great job. Now what we are going to do, you're watching the second video of me. And what is the second video of me doing? It is teaching, because this is important. Now, as I'm going through this next part of the lesson, if you have your math journals, please go ahead and start taking some notes. And if you don't have your math journals on you, that is also a-okay. It might just, I promise you it'll be more worthwhile to do so. And what we're going to do now is go through the PowerPoint about prime factorization and all of the fun stuff that goes with it. So what I'm going to do is I'm going to share my screen. We're going to go to this lovely thing right here. And we are going to learn all about prime factorization. I love the orange color scheme. So prime factorization, our first question here, and I want you to take notes here if you can. What is a prime number? Now, I know we've learned about this before, but I think it's important that we learn about it. Just kind of review it again. So prime number is a whole number that is greater than 1, but that cannot be made by multiplying other whole numbers. So the only way you can get a prime number is multiplying 1 by itself. The first few prime numbers that we have are 2, 3, 5, 7, 11, 13, 17, 19, and 23. That's a lot of prime numbers. Some examples of the prime numbers. Why are they prime? Because they can only be made by multiplying the number by 1. So if we look at our examples here, we see 2 is a prime number. Why is it a prime number? Because it can only be made by multiplying 1 and 2 together. And it's the same case with all of these numbers all the way up to 17 and even further beyond. So like 11, it can only be made by multiplying 1 and 11. You can't multiply 2 by something in order to get 11. No, it's just 1 and 11, and that's why it's prime. Our second definition that I want us to remember is composite numbers. So what is a composite number? A composite number is a whole number that can be made by multiplying other numbers besides 1 together. Now, the first few composite numbers that we have are 4, 6, 8, 10, 12, 14, 15, 16, 18, 20, 21, 22, 24, and 25. Oh my goodness, that's a lot of composite numbers. Wow. So what makes a number composite? Because they can only be made by multiplying multiple numbers together. So an example of composite number is 9. You can multiply 3 by 3 to get 9, and 1 by 9 together to get 9. So there's multiple different factors over here that we can multiply together in order to get this number over here on the left. I don't know if you guys can see my cursor, but like number 12, you can multiply 2 by 6, 3 by 4, 1 by 12. Any of those numbers multiplied together will get you 12. It's not just 1 times 12, and that's why it's composite. When I keep saying factors, what does factors mean again? Factors are the numbers you multiply together to get another number, or a number that divides evenly into another number. The second definition is going to be the one that is most helpful for us. I know I'm moving kind of quickly, but this whole presentation is also available on Google Classroom under the materials section. So for example, the factors of 8 are 4 and 2, because if you multiply 4 and 2 together, you can get 8. Or 4 and 2 are numbers that divide evenly into the composite number of 8. So how do we find factors? We make a rainbow, just like this. This is one of the methods to help us find the factors of a number. So if we look here, we see factors of 18. 1 times 18 gets you 18, 2 times 9, and 3 times 6. So each number is linked by a bow to its partner, and the product of each pair is 18. Product, again, being number times what number gets you the answer of a multiplication problem. But what about prime factorization? That's what we're going to be focusing on today, right? So prime factorization is finding which prime numbers, the numbers that can only be multiplied by 1 to actually make the number, can be multiplied together to make the original number. For us, this means trying to divide the larger numbers that we have into all of the smallest numbers so that we cannot divide the numbers anymore. So this is what we call a prime factorization tree. So what we're trying to do is break down this large number 30 into its own factors, the numbers that can be divided wholly, right? So we break down 30 to see if we can break those numbers down into even smaller numbers. So what we're doing now is we're breaking down 30 into its factors, which are 2 and 15. And then we're going to see if 15 can be broken down even further into its prime numbers, which are 3 and 5. And once we can't break down the numbers anymore, that's when we know we have all of the prime numbers and we are good to go. We're going to break this down step by step. So the first step is to find the factors of the large number. I'm going to start with number 20 here. So 20 is a rather large number when it comes down to it. And the main factors I first think of when I think of 20 are 4 and 5. So this is step 1, just find the factors of the large number. Be sure to take these examples down in your notes as well. But what do we do now? So step 2 is to break down any of the factors that we've made of 20 into their factors. So 5 is okay, right? 5 is a prime number. So we can circle it to show that we are done with this number and we don't need to touch it anymore. The 4 can be broken down even further, right? Because 4 is 2 times 2. That's one of its factors. When we do factors, we can't just do 1 times 4 or something, right? Because that's not really breaking it down anymore, right? Because anything can be multiplied by 1. 20 can be broken down into 1 times 20. We really want to break it down into the prime numbers. So 2 times 2 is what we do when we get 4. So now that we have all of the small numbers, what do we do here? Once the numbers cannot be divided anymore, what we're going to do is we're going to circle them to show that they are done, just like we did with the 5 back on the first step. Now that we have 2s, those are prime numbers, we're going to circle them to show that they're done. And that's what we do with that step. And now that we have all of our prime numbers circled, what do we do here? Do we have our answer with this? Close, not quite yet though. So now that we have all of the prime numbers, what we can do is we can write an equation for the larger number, which in this case is 20, right? To write the equation, we rewrite all of the circled numbers from least to greatest and put the multiplication symbol between each of the numbers. This is going to give us a rather large multiplication equation that will end up equaling our larger number. In this case, what we're going to do is we're going to write 2 times 2 times 5 equals 20. And this is the big multiplication sentence that we have that will get us to equal our larger number. Now, I know that we have multiple 2's and they're the same number. And you might be asking, can we just put 1 2 in the equation? We'll be fine. You actually cannot. What you have to do is you have to put both of them in, or else the numbers won't equal up, right? Because 2 times 2 is 4, and 4 times 5 is 20. So if we only have 1 2, it would be 2 times 5, which is just 10. And that's not the equation we want, right? We want it to equal 20. So every time we make one of these prime factorization trees, which is going to be our main focus today, we have to finish by writing an equation just like this so that it can be simple and we don't have to look at this big old tree and we can understand all of the prime factors of the big number. So 2 times 2 times 5 equals 20 is going to be our answer. And this is the prime factorization. This is all of the prime numbers that 20 has. And this is how all of our answers should be written. And all problems should be solved using this prime factorization tree right over here. To help you out on the presentation that you'll find on Google Classroom, here is a list of all of the prime numbers you need all the way up to 1,000, right? That is going to be really, really big. The biggest thing you're probably going to have to get to is all the way up to maybe 23 at most, I would assume. but just in case you need it for anything else in the future, all the way up to 1,000 is what we have here. And if you need any other resources, or if your parents would like to help you out a little bit and you need some help, there are some other links here that you can find to help you figure out everything that's going on. I'm going to stop sharing for a moment. I've been recording this whole time. I have been recording. All right. So we are going to go back to our whiteboard, and we're going to try just a couple of examples because I think that'll be really helpful for us.